We are now in section 7.4, and the title of section 7.4 is Trigonometric Identities. I know you've already listened to one of the author's videos. I want to jump in right here before we start the other part of his videos, and I want to tell you that in your document sharing in My Lab Math, there is this piece of paper. It's actually one whole piece of paper, but all you need is half of it. And these are just some tips and tricks and ideas and thoughts from along the way that I'd like to share with you to keep in mind. You can't use this paper when you're doing the test, but I do believe the more you look and watch and think and at least have some plain pieces on what to do on identities, the better they're going to be. This is one section you cannot rush. You have got to take your time. You've got to let pieces and parts sink in. You've got to start and stop these videos a bunch, and then even back up and say, now what was that? And let me see that again. Identities take time. Identities take practice. And you'll even see in my notes where I say assign some more homework to yourself from the book to get more practice proving trigonometric identities. So this piece of paper is what I wanted to go over with you. So I'm going to walk through this, and starting with that we should start with the gross side. And I put a check mark by the ones he mentioned in the videos. And so when we start with the gross side, and I think he might have said the more complicated or more involved side. And so when you look at an example like example 4, when you look at example 4, you've got a complicated side and an uncomplicated side, and I'll say this side's the gross side. And so when you're trying to decide which way do I start on these identities, a good rule of thumb is to start with the gross side. Another thing to do, like up here on example 2, another tool, trick, tip to keep in your mind is when you do get identities and they're asking you to establish them, then one thing you can do is change everything to sine or cosine. But you got to have these playing pieces in your mind and where you can go grab them when you need them, and then try it. And if it looks like you're not getting anywhere, don't erase it. Go grab another piece of paper or another part of the paper and start over doing another one of these tips. But a really good one is to change everything to sine or cosine. And even looking at this one right here, they started with the gross side. This one just had one piece. And when they did, they changed cosecant to something with sine and tangent to something with cosine and sine. And voila, you can remove the sines and you're almost there. So another tip is you're going to end up having some pretty gross looking fractions. And so right here on example 6, you see this side, which is going to be our gross side. And when you see this, it's a fraction plus a fraction. So you can see my little note I've got for during lecture. And I'll go ahead and show you. And by the way, if you have any siblings or kids in elementary school, do not show them this trick. They will get kicked out of elementary school. And not really, but they want them to learn the way to find the least common denominator. And this is just kind of a cheater way to get the job done. It's not the least common denominator, but it gets the job done and you can move on. And so what this little ditty does is, if you have a fraction plus a fraction, even like this fraction and especially like this fraction and this fraction, you can multiply, and you always have to go this direction. You can multiply that direction first. So I've got to multiply my a times my d first. And if you're looking at example 6, we would multiply sine times sine, and right there we would get sine squared. Ooh, I can do some stuff with sine squared. Then you're going to need to multiply the other way. So then you're going to need to multiply that direction, b times c. The sign you put in the middle is whatever sign you had. And if I was a plus, I will put a plus, and let's even check what they're doing here. And so right here, I'm going to focus again. Even right here, we did this side times this top times this bottom, and we got our sine squared. Now we would do the bottom times this top, and we get a 1 plus cosine theta times a 1 plus cosine theta. And so we're adding in a 1 plus cosine theta squared. And a silly thing I like to say in class is that's not a 1 and it's not a cosine. It's a 1 plus cosine. 1 plus cosine. And you have to treat it as its a whole binomial. You can't take it individually. You got to take it all or nothing. Well, then back to this. And once you finish up multiplying this way to get the AD, this way to get the BC, and putting the sign in there, then you multiply bottom, bottom. That's where you get your common denominator. And so they would have done that here, where they then multiplied this denominator, 1 plus cosine, times this one, which is this times this. And we'll even hold off multiplying those because some really cool things can happen. So I'm trying to go over my tips sheet, which is in my math lab, or my lab math, in the document sharing. Another one to keep in mind is that you can factor. Factor using difference of two squares or factoring out a GCF. And you got to remember on difference of two squares, you just got to remember something like x squared minus 9. This is a squared term. That's a squared term. And you have a minus, which means you have a difference of these two terms. And you might want to go back and look at some college algebra or algebra 2 and remember that the way you would factor this is that form. And so you've got to recognize, you know, my x squared and my 9, and I didn't pull out an example for them. They may not look exactly like that cute little a, or x squared minus 9, but you're going to have to keep that one rolling around in your brain that it is a possibility. Oh, look right here. It's going to happen right here on this one. So example 4 down here at the bottom, we'll eventually get to it's a sine which is squared minus a cosine which is squared, which perfectly fits a thing squared minus a thing squared. And then when we get down here, they're going to do the 2 sets of parentheses like I did. And they're going to take whatever this is, unsquared, square rooted of, and then this one, the square root of it, and that's what they did. They took the sign, it's squared, and just put one of the signs and one of the signs, because sine times sine is still sine squared. And then this cosine, they split it up too. One's a minus, one is a plus. Same thing here. One is a minus, one is a plus. So you got to keep rolling around in your brain to keep on alert to look for a difference of two squares. You've also got to look for GCF. Greatest common factor can come out in many places, and just scanning the book, here's one right here. I cannot put these terms together, but they both have a 2. So if I move 2 out front, I can factor it out as a greatest common factor. And then I'll have the 1 left in here and just the cosine here. Quick check. I could distribute the 2 times the 1 and go back to where I was. But you got to keep in mind, to get these identities done, start with the gross side. Change everything to sine or cosine. Remember this little ditty. It'll also work if you have a minus. If you had A over B minus C over D, we would do A times D minus B times C and still put it over BD again. And if anything I'm saying, I'm talking too fast, hit pause, think on it, rewind it, and then keep in mind difference of two squares in GCF. This one, using a conjugate. There will be several times when you're thinking, man, I just can't do anything with this. What am I going to do? And I'm scanning these real fast to see if I can find one. And I think you had one. No, I'm not seeing one. Yep, there is one. And it's right here on page 481. And it asks us to show that this equals this by multiplying the numerator and denominator by this 1 minus sign. And so this 1 minus sign is a conjugate, 1 plus sign and 1 minus sign. The 1 minus sign is its conjugate. And so if you're looking at something going, wow, I don't see anything I can do with that, remember you have the power and the authority to go ahead and multiply in a conjugate. But you can't just throw it in there. You got to throw it in there as a 1. And so I'm looking for where this happened. We're on B. Here it is. They threw it in not as just a 1 minus a sign, but as a 1, because it's the same thing over the same thing. That's a 1. And remember, it's not just a 1 and a sine theta. It's a 1 plus a sine theta. And this is a 1 minus a sine theta. You have to treat them that way. So some other information, always keep your first term positive. So if your first term is not positive, like you got a negative sine squared theta, then we need to go ahead and make that positive by multiplying through by a -1. This is a common mistake I see students make, and so I just wanted to point out, and it's what I've been saying. This is not an X, and this is not a 2. That is an X. You are not allowed, you cannot, thou shalt not, take that X and remove them. Because this is not an X and it's not a 2, it is an X plus 2. And there's not an X plus 2 down in the denominator, so you are not allowed to reduce this. However, on the other side, it is multiplication. You can't when it's addition or subtraction, but when it's multiplication, you can go crazy and get rid of stuff that matches on the top and the bottom. A couple of things that are just always worth saying is you have the power to move around multiplication and addition because they can commute. You do not have the power to mess with subtraction and division because they cannot commute. Just a reminder that multiplying by 1 could look like something like this, and that's what it did look like on example 1B. And this is my favorite. I'll have students get bogged down doing identities, and I have to tell them it looks like a tennis match. Keep looking where you are, where are you going? Where are you? Where are you going? Where are you? Where are you going? Because if in all of this mess, if you'll just take a step back, look at where you are in this identity, where are you trying to go, it's amazing that your brain will go, oh, well look, I'm almost there. One more thing, done. So do keep in mind, keep looking where you are, where are you trying to go? Where are you? Where are you trying to go? And this is also one of my favorites. Make your eyeballs behave, because sometimes our brains want to mess up, change up, just kind of do weird stuff with math rules, but I call it making my eyeballs behave. Make my eyes do step by step by step and not go all crazy and go, oh, well, it's this. And wait, make sure that this is worth this, which is worth this. And then this last one, I cannot say enough. Identities are tough to see. The identities are tough to learn. So you've got to practice, 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 and print this page, hang on to it while you're looking through these examples, but then wean yourself off of it as you're getting ready and preparing for our first test.